Hello pilot, welcome to 14 Day Pilot. What's really happened with Jeju Air 7C2216? For me, it's a huge anomaly that happened. As a Boeing 737-800 pilot and also NTSB Aircraft Accident Investigation School alumni, I'd share my thoughts to you. But one thing that I'm really sure that the bird strike that people talk about it is not a probable cause or a major cause for that accident. I'm going to share to you why in this video. So make sure you follow all the video until the end. And as we know, US NTSB or South Korea NTSC will release their preliminary report about this accident 30 days of the accident. So while we eventually rely on that official document, we can still learn from the available data and use it as a reminder of the multiple layers of risk in the aviation industry. But however, nevertheless, I also encourage everyone not to develop a fear of flying just because of recent accidents or incidents. Aviation remains one of the safest modes of transportation, and these investigations are crucial to ensuring it stays that way. So now let's start about 4 categories that NTSB conclude that always be there in each accident or incidents. They are human factor, mechanical factor, environmental factor, and the last one is organizational factors. Or could be a combination of 4 of those, which is that will lead you into a catastrophic accident. That's what happened in Jeju Air in 2024, December 29. We know that the pilot declared a mayday with possible an engine failure because of the bird strike. It's probably 1 engine failure or probably could be 2 engine failures. But one thing for sure, we know that the airplane was landed without a landing gear. In this video, we're gonna open the data of the procedures in the 737. What happened if you got a bird strike, which is you probably gonna lose 1 engine, or what happened if your landing gear got a problem. It means you put the landing gear down, which is the gear should be coming down prior to landing, but this landing gear is stuck. Is there any backup? Yes, of course. There's a manual extension landing gear systems in the Boeing 737-800. But how if the manual landing gear extension also fail? There's a procedures, we call that a partial or full gear up landing procedures. What we can learn about that, I collected all the data, and also I got some data from the flight radar that I can use that, and even NTSB used the flight radar for the first data collection to see what's really happening there, give you some big picture before we come to the real evidence from the cockpit, from the CVR or FDR. The FDR is flight data recorder, when people also call that as a black box. Now let's jump into the data that I have, and at least we can get a better picture what really happened in this situation. And we know for sure the Jeju Air never tried to do the holding or go around or take some time to fix the problems. Instead, we know that it's continue the approach and land without the landing gear. So let's talk about it. So I'm gonna focus to the anomaly that happened. I got 5 lists at least, and if you have more information, feel free to comment below, and then we can learn from the situation. The thrust reverser, landing gear switch, and bird strike. Based on this footage, I did a screenshot of this footage, and then if you can see here, it's very clear that the engine number 2 got a bird strike. I got another screenshot about it. You can watch the video. Now, there is one thing you have to know. Every jet airplane, they got the thrust reversal system. Every time they land, they can try to open the cascade engine to reverse the airflows to help the airplane to stop moving. It's like an air brake for every jet airplane. Now, if you can see here, it looks like the thrust reverse deploy without the landing gear. Now, the condition required to engage the reverse thrust, 3 items. The radio altimeter senses that the less than 10 feet altitude. So based on the radio altimeters, like the sensors that send to the ground and coming back to the airplane, then the airplane will know how high the airplane from the ground. So we call that a radio altimeters. Or the air and ground sensor is in ground mode with the landing gear, of course, and when the forward thrust levers are in the idle position. So if the thrust is moving forward, there's no way for the thrust levers can be open, it has to be back. So 3 items. The radio altimeter sense that the airplane is about 10 feet above the ground, 2, the air ground sensor to the ground mode, and then the thrust levers back to the idle position. So there's no landing gear, of course there's no sensor because the flight and ground mode is sensed by the landing gear, the switch there. So of course we believe that what happened in the reverse thrust engine 2, why that was open, probably is not because of the thrust reverse systems, but because of the engine damage due to the bird strike. The anomaly number 2, we got the engine flame out or stall here. Okay, it's very clear the engine got flame out or stall, but there's no fire over here. Probably this is the bird, I don't know. But if you see the footage, this is the moment that there's a blast on the right engine. But the problem now, there's no landing gear at all, and I believe they taken these photos like less than 2,000 feet. I'm gonna show you the chart, the ILS approach runway 01. But now if you can see here, before the airplane land, even the short final, there's no landing gear at all here. So the pilot aware or may not aware that they're gonna land without landing gear. The problem is if they aware, they supposedly has completed all the partial or landing gear up landing. We're gonna show you after this, okay? They may have a super bad day, 2 problems at the same time. Engine failure plus the landing gear problems. But however, the pilot never said about it, never declared mayday because of the landing gear, so I assume they're not even aware that the landing gear wasn't down at that time. I'm gonna explore that more. Now, let's say we got an engine failure number 2, which is the right engine, and this is your hydraulic systems. In the 737, you got a system A, hydraulic B, and the standby system. The landing gear is controlled by the hydraulic A, which is this from the left engine, and this is the hydraulic B is from the right engine. And if you see here, you got a landing gear here from the red system, which is A, or the left engine, or the engine number 1, they call that like that, okay? It's not affected by the bird because that was the second engine or the right engine, which is that affect the hydraulic system B, got the trouble. Okay, now is there any backup? Yes, I'm gonna show you this better graphic here. So if you see here EMDP and EDP, the EDP is engine driven pump, and then the EMDP is the electric motor driven pump. Now if you see the number 2 and number 1 here, it means the EDP, which is that on the system A, the hydraulic A, is supported by engine number 1, which is on the left side. Now the electric one, the electric pump here, is supported by engine number 2. So this is a part of redundancy system. It's like a cross backup. Okay, let's say you lose engine number 2, you're gonna lose engine driven pump because there's no pump anymore, the engine is shut down, right? But you have the EMDP from engine number 1 supporting you to give you the power to pressurize your hydraulic from engine number 1 to engine number 2. Now the problem is the landing gear is not even connected to hydraulic B. So there's no reason for the landing gear is not going to work because of the hydraulic problems. You got a point, right? Now assuming we also got a problems with the hydraulics, the 737 still can extend the landing gear with a manual gear extension, which is I'm going to show you after this. And if you see here, there's a landing gear transfer unit. It's a feature from the Boeing to retract the landing gear when the hydraulic system A failed. That's the feature to protect the airplane to clear the second segment when the airplane take off. You're going to learn more advanced flight training program during the ATP, right? That's the first segment, second segment for the safe altitude or safe performance whenever the airplane got an engine failure during the takeoff. But this one is not for the takeoff, so we're not talking about the landing gear. And anyway, the landing gear transfer unit is all about retraction, not for extension. Well, however, pilot was continue the approach. That's a problem now. There's no trial to do holding or execute gear up landing procedures. Now, how I know that? The flight radar is showing very clear path that the airplane keeps straight here. There's no go around. There's no holding. Whatever is that, it's 2,500 feet altitude. The ground speed 157. The vertical speed is 896, which is the airplane is commit to do the approach and land, and I don't see any effort or any deviation from the flight path. Maybe the airplane decide to, okay, let's fix the engine failure first, let's go here, or let's go here to do some holding, request from the approach, right? Or maybe burn the fuel because the airplane is going to have the belly landing. That's a common sense, and everybody learned about it on the flying school. Well, I don't know what happened. That's why I call this anomaly. I know the pilot's aware there's an engine failure, but I believe they don't do like complete engine failure procedures because there's a checklist that they need to run that takes about like 5 to 7 minutes to secure everything. But if the airplane here is with 800 or 900 feet per minute at 2,500, okay, 900 per minute, let's do the math. By 3 minutes, the airplane already on the ground, okay? And there's no way for the pilot to complete the one engine inoperative checklist in this case if they don't move out from the pad. So this is anomaly number 2. I don't know what happened inside. That's why we need to wait until the flight data recorder come in and the CVR. But at least for now, we know for sure there's nothing to do with the burst strike. Even though there's a burst strike, guys, we lose one engine, we still have another engine. And then every 6 months, okay, airline pilot, they will have the proficiency check. They will get a simulator training over and over and over again. They will simulate the one engine takeoff and landing. For me, I'm flying the 737, I fly the A320, I fly the Citation. Basically, every proficiency check ride, we will demonstrate the takeoff with one engine inoperative and landing with one engine operative. So this is not normal. I don't know what's going on inside, and let the NTSB or NTSC decide, but this is a very weird situation. This is an anomaly that I can raise and share to you. Now, let's say they have the landing gear jam in the up position. There's procedures, that very long procedures, more than 10 minutes. Okay, there's no way for the pilots to keep straight all the way to runway 01 without doing this if they know that the landing gear is not extended. Just common sense. You don't have to become a pilot to understand this. Okay, this is like a common sense for everybody. If you see there's a steps here, okay, manual gear extension handle all pull. Let me show you the video how we extend the landing gear manually. Here's the video.
Hey guys, and welcome to the Boeing 737-800. I want to show you something really special. This is a very important component. Down by the first officer, on the floor, there's a special little compartment. This is for the gear manual extension. Why is this important? Well, in normal operations, the aircraft is running hydraulics. Pilots can retract or deploy the gear utilizing hydraulics. But in a case of failure in hydraulics, pilots are capable of gravity dropping the gears. Those handles you saw right there are attached to cables, and those cables are routed to the gears. This is the nose wheel well. Top left right there, that's a locking mechanism. Those cables are attached to that locking mechanism. This is what releases when those cables are pulled. Let's go take a look at the main gear. Same thing, the cables are routed down to the main gear. Pay close attention to what I zoom in into. When you pull that cable in the flight deck, the control cable turns the quadrant in the extension linkage. This pulls the control rod and turns the lever. When the lever is turned, the uplock actuator gets released. Look closer, you'll actually see a spring there. Cable gets retracted as well. And right next to it is the uplock actuator, the one with the springs. Take a look at the strut. You'll see a little knuckle. That gets locked into that uplock actuator. That's it.
Now you know. We're gonna pull the cable, and then gravity force will take the landing gear drop. No matter if you don't have the hydraulics, at least if you try to open it, if the landing gear is stuck, you will see visually from the footage that the door probably gonna open like a little bit open, you know, it's not like 100% closed, because that's how the pilot do. They pull it, the landing gear will go down. But of course, again, you need to hold at different position. You cannot just continue approach, and while doing that, you need to go somewhere else and then do all these procedures. And especially if you see the manual gear extension, 1, 2, 3, 4, wait 15 seconds after the last manual landing gear and so on, and then go to step 6 and so on. There's a procedures to do manual landing gear extension. There's trials here and take some time. If the landing gear is still stuck, there's another procedure called partial all gear up landing. You need to have plan for flap 40. If you see the flap 40, okay, you will see there's a flap like this. If you take any flights and then you sit on the window side, every time you see the wing, every time it's landing, normally the Boeing 737 will use the flaps 30, okay? You will see that the flaps will go down like this. It's very clear that the forward flaps go down and is not flat. But you can always see the airplane never put the flaps more than 30 because it's flat, you see? The flap is maybe at 15 because they got an engine failure. Because whenever you got a one engine operative, you probably will land, most likely, because that's not the procedures, with the flap 15. Well, if they were aware that the landing gear cannot be extended manually, and then they need to do partial or gear up landing, there are two things. First, the flap should be in the 40. Number two, they should declare and ask for the ground emergency equipment to make sure everybody ready for the belly landing. From whatever I heard, I cannot find any pilot distress call that they are in the problems of landing gear failure, you see? So that's anomaly number 2. Now, the anomaly number 3, which come first? Landing gear issue or bird strike issue? This is the first bird strike footage that I can get, right? And this is possibly the ILS Zulu runway 01 that they shoot, okay? So every pilot is gonna flying instrument in the airline, and this is the way we're gonna shoot the approach. So the first altitude here is kept up is 3,000, okay? And then the final approach fix on the ILS will be 1,700 feet when we intercept the glide slope, and this is the glide slope, okay? It's depend on the operator, but the Boeing said on the FCTM, when you're gonna lower the landing gear when the glide slope alive, that the landing gear down, okay? That's a moment. Now let's assume they intercept the glide slope here and they decide to lower the landing gear between 3,000 and 1,700, probably about like 2,000 or 2,500. When they see the glide slope is already moved, they put the landing gear down. Well, that's the moment that they should realize that they don't have the landing gear. Does that make sense? But I'm not sure how high this footage was taken, because it looks like a zoom from the mobile phone. But let's assume they got a landing gear issue at the 2,500. I'm not sure whether the bird can fly more than 2,500 or maybe 3,000. Some bird can, but in this case, probably not that high, you know. I don't think that 2,500 you will get a potential bird strike. Most likely bird strike will have after takeoff probably like less than 1,000 feet. So in this case, let's say they extend the landing gear about like 2,500 to 3,000, they will get the landing gear issue first before the bird strike. Does that make sense? Okay, I don't know what's the Jeju Air SOPs for the landing gear, but most likely that's gonna be the procedures of any Boeing 737-800 pilot. In this case, when they got a bird strike, I see they lowered the flaps here. There's a flaps, I believe. Okay, it's not clear, but probably this is the flaps. Before the landing gear down, we're gonna put the flaps 5, and then put the landing gear, then flap 15. In this case, they don't put the landing gear down, so I assume they're around 2,800 to 3,000 or maybe more, or maybe lower. So we really need to get the data later, but I don't see any landing gear here. So you decide, what do you think? Landing gear first or bird strike first? Okay, but definitely they have two problems at the same time. Is that a Boeing fault? I don't think so, because there's a procedures that the pilot never done it. Based on the flight radar, they just keep straight all the way straight to the north, which is that's runway 01, and try to land without doing the go round. And then if they decide to do misapproach here, here's the misapproach procedures. They can do the misapproach here. Climb to 5,000 on track 001. Okay, climb to 5,000, not landing, just climb back to 5,000 and then turn left, do group line and do hold here. There's a mandatory 5,000 they need to do hold here. They can take forever there. They can take an hour to burn the fuel. They can take like 2 hours, whatever they need, right? But at least they need to do something, not just shoot the approach. So if they have the landing gear issue, they should already go round. They shouldn't wait until 1,000. They will not wait if they aware that they have the landing gear issue. Number two, if they get a bird strike first and they think that I'm gonna land, well, by the time they reach 2,500, I believe they already extend the landing gear. But what happened here? If they get a burst strike issue and then they put the landing gear and the landing gear stop, anyhow they should go run anyway, right? Because they need to pull up the QRH and get a normal checklist for engine fail. You see? So that's a problem now, right? So the weird situation, I don't see the airplane flap was set more than 15 degrees. So it means it's definite engine failure because nobody gonna set more than 15, even though they've got a 30 degrees flaps, we're gonna retract back to 15 to reduce the drag. Ground speed only 144 knots. Why on earth they put a 144 knots on the ground speed and they don't have a flaps more than 15, okay, based on the visual again. And then the 800 feet possible manual flying and the vertical speed beyond 1000 feet stable approach. If you can see here, at 800 feet, their vertical speed is 1152. It means they already disconnect the autopilot, disengage it, and then they fly manually, and then the vertical speed is more than 1000, which is that's the limitation of the stable approach. 100 or 200 more than this, they're probably gonna get a sink rate call. It's like maybe 1400, right? They will get a sink rate. It means they're not stable flying with the hand. But if you try to play around with the flight radar, you will see that they made a correction after that. But the speed is still low. I don't understand why the speed is 144, the ground speed. Okay, I got a weather data, the METARs on that day. So the anomaly number 4 now is we're talking about the unstable approach and GPWS, the GBWS. The hand flying is not following the correct lateral path. If you can see here, when they reach 1000 feet, the speed is about 145, and initially they're flying about like 768 feet per minute, and when they drop to 800, now it's become 1150. Probably they are not following the flight director. So the hand flying is a problem here. We can see for sure that the hand flying was an issue. The pilot probably not really proficient to fly the airplane manually in a single engine situation. Okay, where is the GBWS landing gear warning? Because if you fly at a low altitude without the landing gear, they're gonna call you like too low gear, and then the horn is always there and you cannot silence the horn. Why was it ignored? That's the anomaly number 4, right? And this is the EIDI for the pilot. This is the PFD, primary flight display, the display unit. If you see here, this airplane is following the flight director to shoot the approach. This is ILS approach, this is the localizer, and this is the glide slope. And this one is the flight director, okay, FD. And of course, this is under autopilot because you got a single pilot, glide slope is captured, localizer is captured. Okay, it's very clear this is ILS, and you got an ILS here. Now, the airspeed is 144. So I got this example, 144 indicated airspeed, okay? And this is their approach speed. The VRAF 30 is 140, plus 5 is 145. So this is the VRAF 30. It means the airplane is doing the approach with 2 engines with the flaps 30, okay? It has 144. Now, this is what I'm confused. Why on earth this airplane is flying with a single engine and supposedly flying with the flap 15, but the ground speed is 145? That's too low. If you can see here, the vertical speed is 800 feet per minute below, okay, below 1000. So if the pilot had complied with the one engine inoperative landing procedures and used ILS with autopilot with vertical speed, would have not been lower than 1000 feet per minute below 1000 feet AGL. That's pretty sure. A ground speed, okay, the GS, of 144 knots based on the METAR. This is the METAR during the situation happened, okay? You got a 110, 2 knots. So indicates that the true airspeed was too low for a flap 15 approach, especially with over 180 passengers on board. So probably they should be at 165 to 170 ground speed, okay? Especially the wind is calm here. And if you can see, the slope of this approach is about 3-degree slope here, right? Based on the glide slope, 3-degree slope, they supposedly not descend too steep, right? Does that make sense? Because that's only 3 degrees. So in that case, the 1000 feet per minute, more than that is not normal in the situation. This suggests that the one engine inoperative procedures was not properly applied. We did not observe the airplane execute a single engine go round, despite the fact that the 737-800 is fully capable of performing one. Remember, the 737-800 is very reliable and very capable to doing the single engine go round. Anomaly number 5. Why didn't the pilot try to fix the issue before deciding to land with a possible engine failure and no landing gear? This is the biggest questions that I and maybe you and maybe everybody will ask. The airplane is flying like an S-turn here, non-stable with the VS, below 1,000 feet, with the condition that they know for sure, they call a mayday for the engine failure, with the landing gears not down, but they didn't do anything to fix the issue. They don't go for the public misapproach. They don't try to declare that the landing gear is not down. So I don't know what really happened here. Now the possible contributing factor based on the NTSB category. Human factor A, the CRM crisis, seniority problems. This could take apart as a contributing factor in this accident. Refer to the Jeju Air Flight 214 at San Francisco. That's also the CRM and seniority problems on the South Korea side. Fixation that caused lack of situation awareness. Both pilot focused on the single engine problems and forgot about the landing gear. This could be like that. Poor training and CBTA application. CBTA is competency-based training assessment. And poor aeronautical decision making, the ADM. It's very clear the pilot should aware that they need to fix the problems. Their job is to run the checklist before they continue the approach. Mechanical factor, poor maintenance control. There's a rumor about previous prolonged problem in the landing gear, but I don't know, okay? Whether that's a rumor or that's a fact. So let's the regulator find it. Compliance to mandatory inspection or Boeing Service Bulletin or Airworthiness Directive related to the landing gear. This has probably become a contributing factor as well. How about the environmental factor? Of course, the bird strike caused an engine failure, which has created a threat. But again, this is not a biggest threat, and everybody will be trained in single engine takeoff or single engine landing, handling any failures like this when you become a jet pilot. And the last one is organizational factor, possible poor company governance and safety management, and create a bad safety culture in flight operation department. So what could have done better, guys? Aviate, navigate, communicate. It's always aviate, navigate, communicate. The Boeing 737-800 is highly capable and reliable aircraft, able to handle engine failures and landing gear issues. Number 2, the pilot should have considered executing go-around to address the problem step by step rather than continuing the approach and landing unless the aircraft was in a minimum fuel emergency. However, no emergency call was reported from the pilot about the fuel, right? Number 3, the pilot never declared the landing gear malfunction, even they were fixated on the engine issue. The GPS warning to low gear and the continuous horn, which cannot be silenced, should have alerted them. The pilot monitoring, which is the pilot that's not flying, this could be the co-pilot, could be the captain, it depends who's flying on that leg. We call that a non-flying pilot, plays a critical role to ensuring the aircraft returns safely. It means their job is to monitor what happened there. Let's say we got an engine failure and the pilot flying is busy flying the airplane, but you got a second pilot to watch you, to run all the checklists. Now what's happened with the co-pilot? Okay, this could be he was too scared to remind the captain. It was happened with Garuda Indonesia in 2007 when it was overrun because it landed too fast with the approach speeds more than normal, and then the co-pilot didn't do anything to override the controls because the captain's really senior and he said like, I'm the senior pilot here, I know what I'm doing. So that was the accident happened, right? And number 4, to enhance safety, there need to be an emphasis of improving decision making, CRM, quality, and reducing the influence of seniority culture in South Korea aviation industry. Well guys, we already know what we know today. We're gonna wait until the final conclusion from the NTSB or NTSC. Well, deepest condolences one more time, and then I hope that you're gonna learn from this video to become more aware as a pilot in command. Aviate, navigate, and communicate. You can always go around and fix the problem up there. Do not force yourself to land the airplane in the worst condition without any preparation before. Safe flight for you. Until next time, and God bless you.